All right, so we'll begin the chapter by thinking about and defining what is a sustainable development. Now, we want to think about it especially in the context of finite, non-renewable resources, so things like oil, copper, minerals, etc. Right? In with oils or with things that's non-renewable, right? How do we use it in a way that is sustainable, right? Is sustainability of finite resources even possible, right? Because for every ton of copper that we use up today, it will not be available for the future generation, right? For every gallon of oil that we use today, right, it will not be available. Okay, so in 1987, the UN set out to answer this question to define what is sustainable development. And here's the definition: development that meets the needs of the present without compromising the ability of future generation to meet their own need. So basically, in essence, it's about opportunity. Right? We today we have opportunities to sustain a particular way of life, and that is due to our usage of natural resources. And so, for the future generation, in order to be sustainable, we just have to make sure that the future generation have the same amount of opportunity, not necessarily the same amount of resources. Okay? All right. So the question that we're going to try to answer is how much of a finite, non-renewable resource should we use now, and how much should we save for the future? Okay. In other words, right, what is the optimal allocation of finite resources? Now, in order to do this, we need to make some modification of the supply and demand functions, or the supply and demand model that we have used before. Now, supply is marginal cost, demand is marginal benefit. Now, you want to give it is more appropriate most of the time to refer to supply as marginal cost and demand as marginal benefit, because a lot of times we don't necessarily have a market, right? And so by using the phrase, the terms of supply and demand, and sometimes it doesn't make sense. All right, so but they're interchangeable. Okay, now we will introduce now a new term, marginal net benefit. Okay, the net benefit of consuming or production of an additional unit. The definition is very simple, just marginal benefit minus marginal cost. Suppose that your marginal benefit is this function here, and your marginal cost. Then to get the marginal net benefit, it's very straightforward. You just subtract, subtract each other. Make sure you carry the negative, and we get this, more compact function. Right now, or compact equation. Now, why is this necessary? Well, it doesn't actually give us any more information, okay? But it is helpful, as you will see in just a few moments. Why we need to condense this? But to show you that it doesn't give us any new information, let's look at the optimal. So before, the optimal allocation, or the optimal equilibrium, is when marginal benefit equals marginal cost. Right? Now you will see mathematically that is equivalent to marginal net benefit equals zero, right? Because when they're equal to each other, you subtract them, and then this will equal zero, right? And so they will give us the same result, right? When you have a marginal net benefit equals marginal cost, we can observe that the optimal is at 200 tons, and when the marginal net benefit equals zero, we see also the optimal is at 200 tons. Okay. Now you do notice that we lose the price. Right? So here, this is the price, and here, this is just dollar. This is not price, so don't make that mistake. Right? So where the price is not zero, right? It's just that the marginal net benefit is zero. So in this context, we will say this is the marginal net benefit to society. Okay. Oh, one more note. Here, we're going to assume that the marginal cost curve, this is the black line here, the marginal cost curve, represent all of the costs. So that includes extraction costs, environmental costs, production costs, etc. So there's no externality. That's here. So everything, all of the costs to society is here, which that means, right, this marginal benefit and marginal cost is also the social marginal benefit and the social marginal cost. Okay. So what should we call the area under the marginal net benefit curve? We'll just call that the total net benefit. So anything under the marginal is just called the total. and this area is the total net benefit to society, right, at least this period, right, of consuming this much copper. So the socially efficient equilibrium, we will define that. We will define that at when the social marginal benefit equals the social marginal cost. This is when social welfare is maximized. Now we didn't call it, the equal marginal principle before, so we'll introduce that now. So, but you already seen this condition in chapter 3. Right? So this is the equal. So the equal marginal principle is that when social marginal benefit equals social marginal cost, social welfare is increased. Okay, and we can see it pretty easily here, right? That why that maximizes the social welfare, because at this point, if you consume any less, there's more benefit. The benefit is greater than the cost. If you consume any more, then the cost is greater than the benefit. And so, by consuming at this amount, no more, no less, we will maximize the social welfare. All right. Now, when we're talking about one single time period, we will call that the static equilibrium. Okay, so right now, this is 200 tons is the optimal amount, right? If we only have one time period to consider, and that is the static equilibrium. Okay. Couple things to think about. Did the problem state the total reserve of copper? No. Right? And we didn't use that information to solve for the optimal. Right? So looking back, when we solved for the 200 tons, all we used was the marginal benefit and marginal cost functions. We did not consider the the total reserve of copper in the ground. Suppose the total reserve is 250 tons, then, right, our optimal is 200 tons, then we're leaving 50 tons in the ground. Why? Okay, so the way we want to think about it is, the cost of extraction of the 200 tons is greater than the benefit obtained after 200 tons. Right? Marginal cost. So marginal cost is greater than marginal benefit. Right? So just because they're 250 tons, right? For the current period, we will not consume all of it. Not because we're trying to reserve it for the future generation, but simply because the cost of extraction is too high. Right? Okay. So, all right. So that is the static equilibrium. Okay, and keep this number in mind. This number is going to be important. Right. So when there's no consideration for the future generation, when we just want to maximize the current generation, we will extract 200 tons. Okay, and that will maximize the welfare for now. Okay, now the question we want to move on to is, what is the dynamic equilibrium? Right. So how much should we extract in Q1, Q2, Q3, Q4, and maybe so on?